Let's take a moment to talk about another aspect of creating objects that's quite interesting and quite useful. So useful, in fact, that many libraries and frameworks include a very similar feature called extend. And extend is possible because of something called reflection. But first, reflection. Sounds complicated. No, it's not. Big word alert. Reflection. An object can look at itself, listing and changing its properties and methods. So, a JavaScript object has the ability to look at its own properties and methods, and we can use that to implement a very useful pattern called extend. Here I have my person object again, and my John object, and my don't ever do this in real life setting the prototype. So John's prototype is person. Now, we're going to show an example of reflection in JavaScript. I'm going to use the for in statement in JavaScript. If you're not used to that, it's something like the for each. But I can say for, and declare a variable, let's call it prop for property, and then in, and then John. What this will do is loop over every member in the object. For in. Kind of like looking at the length of an array and looping across all of its items. We can loop across a collection, and for every loop we'll have a variable called prop that will be the current item that we're looking at. So this is going to loop over all of the members of the John object. And I can simply console.log. Remember, those are name-value pairs. So prop will contain the name. I'll just put a colon. And then I'll go look at the John object and grab the value based on the name. And remember that I don't have to use the dot operator. I can use the brackets operator, which accepts a string as the property name. And I'll just do that. So this is going to loop over everything, every property and method in this object. This will be the name, and then I'll use that name to go grab the value. Make sense? All right. Ta-da! The name and the value. The name and the value. And hey, wait a minute. The get full name. Remember, the get full name is actually on the prototype. So this for in actually reached out and grabbed every property and method, not just on the object, but also on the object's prototype. Well, that can be useful, but what if I just want to know what's on the object itself? There's a way to do that. I can say if John, and then I can check. There's a property on that base object way down below, so it's on the prototype chain. It will be, I look for has own property. This doesn't sit on John. It doesn't sit on person. It sits on that base object that JavaScript has. This is a method on that base object. And what you can give it is a string. I could say like first name. And this will tell me if this object really has this property. If it does, it will return true. If this property isn't on that object, maybe it's on the prototype, or maybe it's not anywhere in the prototype chain, it will return false. So I can check and see if this prop string is actually on the John object. So it will only log it if it's really on there. So what I should see there, first name, last name, because that's what is really on the object. So I can reflect on the John object, look at its properties, look at what's called metadata of its properties, whether it's really attach to that object or not. List it, and I could change it and do things with it. This concept, in turn, lets us implement an idea that's also very useful, a complement to prototypal inheritance, so to speak. But it's not built into JavaScript. So many frameworks and libraries build it themselves, write some version of it, because it's so useful. Let's use the underscore library. I've already grabbed underscore.js. And I'll show you what this looks like. It's called extend. I'm going to go ahead and make a Jane object again, but she's just going to have an address and a get formal full name function. Got that? So she has a property and a method that I may find useful. So does Jim. We'll make another one, and he's got another property I may find useful. Get first name, let's say. And this will just return the first name. Notice that I'm not putting these into the prototype chain. Maybe I don't want, for some reason, maybe they have a lot of other properties and methods I don't want to be in that prototype chain for one reason or another. Or maybe I want to simply use them in a different way. Maybe they are useful individually, but not as prototypes of each other. So what I can do with the underscore library, for example, underscore.extend. John is what I want to extend, and then I can give it other objects, a list of other objects. And what this does is composes or combines these objects. It takes all the properties and methods of these other objects that I give it, and it could be a big long list, and adds them directly to John for me. I could do this myself, but this is a really nice feature. So if I output John, you'll notice that he now has the address from the Jane object, the get first name function from the Jim object, and the get formal full name function from the Jane object, as well as his original first name and last name properties. And he still has his prototype, which is the person object, where I have get full name. So you saw this is very different from the prototype chain. This physically actually placed the properties onto the John object. We composed, we combined them. How does this work? Well, let's go to our underscore.js source code. Remember, we want to not be afraid of getting an open source education, of looking at this beautiful source code and learning from it. And we have the tools we need to understand it. All right, so I'm going to look for extend. Okay, I found it. It's creating this property or this method on this object, which is just called underscore. It's calling a create assigner function. So we need to go find that. Let's see if we can find, there it is. Create assigner. Well, this is actually a function. That makes sense. And it takes some keys and then it returns a function itself. All right, so this is creating a closure. Remember that? So this is the function that's actually getting run when we call the extend. And it has a closure access to these other ones. All right, so it looks at the arguments. Remember, the arguments is all of the properties passed in. And it looks at the length, and it says, oh, if length is less than 2, then just give me back the object that I passed in to add on to. Well, that makes sense. If I didn't pass anything else, if length was 1, then just give me back John, because I didn't give you anything to add on to John. That's what that's saying right there. If the number of parameters passed to this function is less than 2, then just give me back this first one. All right, so now it's doing a loop across length. Length is the number of parameters I passed in. So that makes sense too, but it's starting with 1. So it's skipping that first one. Because remember, arrays are 0-based. So it skips index 0. So it skips John. And it moves on to the rest of the parameters. And remember, I can add other parameters here, and I don't have to actually list them, but they're available via the arguments keyword. All right, so it loops through all of the other parameters that I pass, in this case, Jane and Jim. Makes sense? And then it says, all right, go find that parameter. So index 1 would be Jane. That becomes the source. Keys func, we won't bother looking at that, but the keys are those property names, the names part of the name value pair. So it goes and grabs the name of all the properties of that object. So it grabs the names of the Jane object of all its properties and methods, and the Jim object, all its properties and methods on each of these loops. So the first loop, all of Jane's properties and methods, and then loops through them using a for loop across the length of that array. So Jane had 2 properties and methods. So this will be a 2, and it'll loop across those. And then what does it do? It grabs each property and method, and it double checks that it's really there. And then it updates my obj, which was the John object, the first thing passed in, and sets its property or method. It creates a new property or method with that name to that property or method of that object that I passed in to be copied from. Then it does it again for the next one, and so on and so forth until it finishes the rest of the parameters. So what this is doing here is it's using reflection. It's looking at the lists of properties and methods like we've already tried, and it's setting the property and method of my John object, of my destination object, with all of my sources. So it's just basically 2 loops, one inside the other, one loop across all the lists of objects I added as sources, and one across each of those properties and methods. So it loops across these 2, and inside each of these, it loops across its properties and methods and adds them to John using reflection, using the fact that I can set John's properties and methods with the brackets operator and a string name. It sees that Jane has an address, so it sets John, then address in brackets, equal to Jane, then address in brackets. It's copying over a reference to those properties and methods. That's pretty neat. So when all is said and done, John now contains all the properties and methods of these originals. So do you see how reflection is useful, and especially extend? This shows up in a lot of frameworks and libraries because it is so useful. You can compose objects. You don't even need the prototype chain always. I can use this pattern, and it's quite powerful. And by looking at the source code of underscore, I learned something. I learned how to write some better code. I learned something useful that I could reuse myself. I could even pull that extend method out of underscore if I pulled along with it whatever it relied on, and could just have it by itself in my own library that I use for my own project. Pretty cool. One caveat here. In the next version of JavaScript, there also will be something called extends with an S. That's going to be used to set the prototype. I think that's a little unfortunate because I like the concept of extend, but that'll still be around. It's just a very similar keyword will mean the prototype. And when we talk about this, we'll be talking about this composition. We'll see what happens over time. But for now, understand that you can use reflection to also have this extend pattern, not just the prototype pattern, to combine and compose objects. All right, let's move on.